Chapter 3, Earth Systems and Cycles. Section 2, Heat and Energy. Before you read, after you read this section, you should be able to answer these questions. What is temperature? What is heat? How does heat move from place to place? What is temperature? What makes an object have a certain temperature? The answer to that question has to do with the tiny particles that make up the object. All matter is made up of tiny particles. These particles are always moving, even though we can't see them move. When particles are moving, they have a kind of energy called kinetic energy. The faster the particles move, the more kinetic energy they have. The particles in an object are all moving at different speeds and in different directions. We can't measure the kinetic energy of each particle by itself. However, we can measure the average kinetic energy of all the particles in an object. The average kinetic energy of these tiny particles is what gives an object its temperature. The temperature of an object is a measure of the average kinetic energy of all the particles in the object. The temperature of an object does not depend on the size of the object. If the particles in an object have a lot of kinetic energy, the object will have a high temperature. Alright, I've just found the answer to my first question. What is temperature? So I'm going to highlight the answer. The temperature of an object is a measure of the average kinetic energy of all the particles in the object. So again, I'm going to highlight that with the red crayon. Reading check. Number 1. Explain. How does the speed of a particle affect its kinetic energy? Okay, so we see here that the faster the particles move, the more kinetic energy they have. Well, how does it affect it? The faster they move, the more kinetic energy they have. Take a look. Number 2, identify. Fill in the lines in the figure to describe the amount of kinetic energy in the particles. This material has a low temperature. The particles in the material are moving slowly, so they have a low kinetic energy. This material has a high temperature. The particles in the material are moving quickly. They have a high average kinetic energy. All right, what is heat? What do you think of when you think about heat? Most people think of something that has a high temperature. However, heat also has to do with objects that have low temperatures. In science, heat is the energy that's transferred between objects that are at different temperatures. Why do some objects feel hot or cold? Heat moves from one object to another when their temperatures are different. Heat always moves from the object with a higher temperature to the object with a lower temperature. When you touch something that feels cold, heat moves from your body into the object. When you touch something that feels hot, heat moves from the object into your body. Heat and thermal energy. If heat is transferred energy, what kind of energy is being transferred? The energy is thermal energy. Thermal energy is the total kinetic energy of the particles that make up a substance. Thermal energy is measured in joules. The amount of thermal energy in a substance depends partly on its temperature. Something at a high temperature usually has more thermal energy than something at a lower temperature. Thermal energy also depends on the number of particles in a substance. At the same temperature, objects made of many particles have more thermal energy than objects made of few particles. So it seems like I found out the answer to my second question, what is heat? It says here that heat is the energy that's transferred between objects that are at different temperatures. And if we look over here, we've got a reading check question number 3. Define what is heat. And it says right here that heat is energy that moves from hot objects to cold objects. Number 4, critical thinking. Compare. How is thermal energy different from temperature? Well, it says right here, thermal energy is the total kinetic energy of the particles, not the average. Take a look. Number 5. Explain. The soup in the bowl and the soup in the pan have the same temperature. Why does the soup in the pan have more thermal energy than the soup in the bowl? And it says right here that there's less soup in the bowl, and we know that the total kinetic energy has to do with how much there is. So I guess it's because there's less soup in the bowl that it has less thermal energy. Reaching the same temperature. When two objects with different temperatures touch, heat flows between them. The heat flows from the warmer object to the cooler object. Heat flows until both objects have the same temperature. How does heat move? Heat can move between objects in three main ways: conduction, convection, and radiation. During conduction, heat moves through matter, but the matter does not move. During convection, matter moves and carries heat with it. During radiation, no matter is needed to move the heat from place to place. Conduction. Conduction happens when heat moves from one object to another through direct contact. Imagine that you place a metal spoon into a bowl of hot soup. The particles in the rounded end of the spoon touch the particles in the soup. Heat moves from the soup into the spoon by conduction. After a while, the handle of the spoon will get hot, even though it's not touching the soup. This is because the metal in the spoon can conduct heat from the rounded end to the handle. So I've found the answer to my third question: how does heat move? And we see right here that heat can move between objects in three main ways: conduction, convection, and radiation. During conduction, heat moves through matter, but the matter does not move. During convection, matter moves and carries heat with it. And during radiation, no matter is needed to move the heat from place to place. Take a look. Number 6, identify. Fill in the blank spaces to show the direction that thermal energy moves between the ball and the water. Number 1, a hot metal ball is placed in a beaker of cold water. The ball starts out with a temperature of 35 degrees Celsius. The water starts out with a temperature of 5 degrees Celsius. Number 2, as soon as the ball enters the water, heat begins to move from it moves from the hot thing to the cold thing, so I know it moves from the ball into the water. The temperature of the water begins to rise and the temperature of the ball begins to drop. Number 3, in time, the ball and the water reach the same temperature. The ball has become cooler and the water has become warmer. Heat stops moving between the ball and the water. Math focus. Number 7, calculate. By how many degrees did the temperature of the metal ball decrease when it transferred its thermal energy to the water? And if we look over here, we see it started at 35 degrees Celsius, and then it ended at 15 degrees Celsius. 35 minus 15 means that it decreased by 20 degrees Celsius. Critical thinking. Number 8, apply concepts. What will happen to the temperature of the spoon when the spoon is placed into the bowl? Explain your answer. So I see here that the heat moves from the soup into the spoon, so that tells me that the temperature of the soup will go down. All right, let's not forget to go back and highlight some of that key vocabulary with the blue crayon. I see the word kinetic energy is in italics, so I'd want to highlight that word and its definition. I see over here that the word thermal energy is highlighted and in bold, so I want to highlight that word and its definition. I see here the word conduction is highlighted and in bold, so I want to highlight that word and its definition.